Hello! Today I'm going to show you how to construct this hot water controller that's made out of a 300 watt inverter board. These are only $5 on eBay, and there's only a few things you have to do and add on some parts. It should be simple enough, but I always tell people to buy a couple of these because chances are you'll screw up one or two of them. Okay, the first thing is between the relay and this connector over here, there's a diode, and that diode has to be removed. And you can take that diode and put it over here on the LED circuit. The band will face the diode. Now, where the diode used to be are two holes. The one closest to the edge is where a diode goes, and the band faces down into the hole. I usually cut a section of wire and strip off the insulation, and that insulation becomes some spaghetti, so it's up on this little standoff here. And I do the same thing with this 10K resistor that goes into the other hole. And here's your TL431. The TL431, the flat section faces down. I just glue it on with some hot melt glue. And over here I put a capacitor. The primary function of the capacitor is to basically hold these two leads apart, because these two leads go off to the pot. This center one is ground. This is the high, and this is the reference pin. Now on the output, these two outputs are tied together, so it's 50% duty cycle on each one of these FETs, and together they can be up to 100%. So that means you get half the heating on each FET that you would normally do if you just were putting it through one. That's you know, this is good for about 10 amps, and the maximum voltage on this is about 72 volts. So you know, a 30 volt grid tie panel, two of those in series is a good match. We feed power into this pin. You know, the factory sheet says you're supposed to feed it here, but we've changed things around on the back, and we feed power in here. This is a resistor going up to the positive source, so this would be 60 volts right here. We have a voltage divider here. This is a 300K going into a 10K pot, and then there's a 10K resistor, and that should give enough range. You can put a resistor across the pot to make much more fine control, and you can do some calculation. I'm not going to do it for you. You know, if you don't want to learn something, you shouldn't be building stuff, because at some point you're going to be all alone and you're going to need to know how to work on this thing. So this is the bottom 10K resistor. And again, this goes back to ground, or the negative. These pins aren't marked very well on some boards, but this one on this side is the negative. This is the positive. Now when you get this whole thing put together, it's going to work like this. This is the first simple test. You can take any 120 volt light bulb and connect it onto here. It'll glow dim. So right now we see it's in inhibit mode because we've set the voltage to higher than what the panel voltage is right now. And if we turn this, you can see it goes to turn the other lamp on. In the next video I'll actually show you how to hook up temperature controls and other things, but this is the basic test. If you can't get it to do this, you've done something wrong. Now let me flip this over. Now we put a, this is a 12 volt center, and that's from this terminal to the other one. There has to be two cuts made on the board. One is here. This disconnects the relay. The relay is a big relay. It takes about 100 milliamps. You don't want it in your system. And so what we do is I just take a box cutter X-Acto knife, and I wiggle the blade across and make a slice. So this is no longer connected. Here's where the diode used to be that we removed, and that diode moved over here. So the second cut is on the ground leg of the LED. Right across underneath there you see the black mark. And then from this LED to the common negative, put about a 1.2K resistor. This isn't too critical. You can go up to 2.2K. Anything will do. It's just to make sure that the light bulb is bright enough when we go into the inhibit mode. And this again, the transistor, this is like a 2N3904 transistor. It's any generic small signal transistor. If you lie it flat, this emitter will, the base will face over here, the emitter will face on over here, so you can just solder it here, solder it there, and the center lead, that lead is left floating. You attach a wire onto it, and that goes over here to the timing capacitor. The oscillator, we short out the oscillator so it stops running, and that turns most of the FETs off. So it's a very simple operation. The oscillator is running about 100 to 200 hertz. These things aren't calibrated at all. There's a pot, doesn't really matter where it's set to. But those are the modifications. Power comes in here. That's the center pin between the 3 pins, and we use a 100 ohm resistor to just bridge from here to there. That's where the relay contacts would have normally been. So we just use that basically as a bridging resistor. 100 ohm, 220 ohm, anything in that range is okay. It's just a little bit of protection in case you should put a lot of voltage on that pin by accident. It'll save the board from just turning into a melted mess. This resistor might burn up, this might short up, but probably the electronics will survive. So that's the modifications. You have a cut here, a cut there. You put the resistor in, and you bridge this transistor across it. The emitter goes up, emitter goes here, the base goes here, and the collector, which shorts out the capacitor, is there. And this Zener, if you are operating this from have a 12 volt battery source, you don't really need to have the Zener. But if you want to have it standalone and run off to 60 volts, you need to have this Zener to limit the voltage that's going to the FETs. And you need a 4.7K 1 watt resistor going to the 60 volts. So those are the mods. It's really not that hard to do. Just take a little patience with it. And all you need is a TL431, some transistor, and a couple diodes. I'll be doing other videos on how to hook it up with a temperature controller, or using the existing temperature controller that's in the water heater. So this is the first start. If you can get it to the point where you turn the light on and off, you've got it made. So thanks for watching.